Design Review Guideline, Basis of Design Compliance. Scope: conduct a comprehensive review of the design basis agreed with the customer to ensure that all engineering disciplines have incorporated all requirements into the design deliverables. Review timing: conduct reviews periodically as determined by the project engineering manager in consultation with lead discipline engineers or their designate. Include a parallel review of all key document change notices, ADCNs, issued during the period, incorporating relevant changes into the BOD. Methodology: review the BOD section by section, ensuring each discipline and facility area relevant to the BOD section under review is considered. Discuss and agree on revisions with relevant disciplines and facility areas. Intended outcomes: validate that the BOD is fully understood and that the requirements stated therein have been met. Ensure the BOD reflects the latest agreed design basis, incorporating any recent changes or updates. Recommended reference documents: Basis of Design BOD document, data sheets, drawings, supplier data as required. Recommended team: facilitator, scribe, project engineer, lead discipline engineers as required. Lead representatives from specialist groups as required. System-specific prompts and scope: detailed review of each BOD section. Ensure alignment with project scope and customer criteria. Verify consistency with other project documentation and design criteria. Additional useful information: consistency checks. Ensure consistency between the BOD and other project documentation such as PNIDs, PFDs, and system descriptions. Compliance verification: verify compliance with project scope, customer requirements, and relevant industry standards. Updates and revisions: regularly update the BOD to reflect any changes in project scope, customer requirements, or industry standards, ensuring all stakeholders are informed of revisions. Interdisciplinary coordination: promote interdisciplinary coordination to ensure that all aspects of the design are aligned with the BOD. Documentation: maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions, to provide a clear audit trail. By structuring the guideline in this manner, it provides a clear and comprehensive approach to ensuring basis of design compliance, promoting thorough and systematic reviews, and ensuring all project requirements are met. Design Review Guideline. Layout Review. Scope: conduct a detailed review of the layout of the process plant, power plant, and off-site facilities to ensure optimal design and compliance with project requirements. Review timing. Timing to be determined by the project engineering manager in consultation with discipline leads or their designate. Methodology: review the layout considering various factors including raw material and product flows, environmental impacts, constructability, local authority requirements, maintainability, and operating risks. Utilize conceptual 3D models or preliminary plot plans where available to facilitate a comprehensive review. Intended outcomes: finalize the overall facility's layout, ensuring it meets project requirements and optimizes efficiency, safety, and maintainability. Recommended reference documents: basis of design, applicable sections, major system PNIDs, relevant regulations, conceptual 3D model and/or preliminary plot plan, 3D model if available. Recommended team: project engineering manager or designate, lead process engineer, lead piping engineer designer, project engineer, construction manager, lead discipline engineers as required, customer representative. System-specific prompts and scope: material and product flows. Ensure the layout facilitates efficient raw material input and product output. Environmental impacts: assess and mitigate potential environmental impacts in the layout. Constructability: ensure the design can be constructed efficiently and safely. Local authority requirements: verify compliance with local authority regulations and requirements. Maintainability: design for ease of maintenance to ensure long-term operability. Operating risks: identify and mitigate potential operating risks through layout design. Additional useful information: integration with other systems. Ensure the layout integrates seamlessly with other systems and components of the facility. Future expansion: consider allowances for future expansion within the layout. Accessibility: ensure adequate access for operations, maintenance, and emergency response. Compliance with standards. Verify that the layout complies with relevant industry standards and best practices. Interdisciplinary coordination. Foster coordination between various disciplines to address all aspects of layout design comprehensively. Documentation. Maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions, to provide a clear audit trail. By following this structured guideline, the layout review process will ensure that all critical aspects of facility layout are thoroughly considered and optimized for safety, efficiency, and compliance with project requirements. DSASH. Design Review Guideline, Discipline Design Review. Scope. Conduct a thorough review of key issues within each design discipline to ensure customer and project criteria have been met. Review timing. Timing to be determined by the project engineering manager in consultation with discipline leads or their designate. Methodology. Review design documentation to ensure all key issues have been considered and satisfactorily addressed, covering various aspects such as process, piping, mechanical, instrumentation, electrical, structural, and civil engineering. Intended outcomes. Produce a review report listing and commenting on any inadequacies identified and recommending actions to ensure these are captured in the design. Recommended reference documents. Lead discipline engineers to provide documentation for the relevant discipline meeting, including PFDs, process flow diagrams, PNIDs, piping and instrumentation diagrams, HAZOP results, basis of design, BO criteria, relevant specifications, standards, and regulatory requirements. Recommended team, facilitator, scribe, project engineering manager or designate, lead discipline engineers, project engineer, customer representatives. System-specific prompts and scope, process, finalized and checked PFDs, signed off PNIDs, resolved HAZOP results, stream compositions, flow rates, temperatures, densities, and pressures, performance risks and throughputs, tankage volumes, vessel elevations, control philosophy, mass and energy balances, and utility requirements, environmental impacts and emissions, low temperature and vacuum design considerations, piping, reviewed and approved plot plan, resolved design review actions, status of upstream deliverables like PNIDs, line lists, etc., compliance with basis of design, BOD criteria, including seismic, snow loading, wind, blast, design life, temperatures, and regulatory requirements. Testing and inspection requirements, standardization and compatibility with existing facilities, vibration and dynamic loads considerations, mechanical, location and layout compliance, statutory and regulatory requirements, testing and inspection requirements, material of construction, vibration and dynamic loads, operating design and testing parameters, reliability, operability, and maintainability. Instrumentation, primary control variables and turn-down requirements, metering and control accuracy, metallurgy and seat material, stability, response time, dead time, and control loop interactions, customers' standard instrument specifications, availability, reliability, and maintainability, considerations for cavitation, flashing, and sonic flow, pressure rating and hazardous area requirements, power and air supply requirements, cable entry, supports, and mounting, interfaces with other systems, low temperature and vacuum design. Electrical, total demand, reliability of supply, motor starting and fault levels, protection grading, earth leakage, emergency power, and future demand growth, voltage regulation, lighting levels, earthing, touch and step potentials, lighting protection and insulation coordination, hazardous area requirements. Structural, stability, strength, and serviceability. Load considerations, transportation, installation, dead, live, temporary, and permanent loads. Environmental load considerations, wind, wave, current loading, and earthquake dynamics. Corrosion protection and access for operation and maintenance. Vortex-induced vibrations, wave slam, marine growth, scour, and interference considerations. Constructability assessments. Civil, surveys including datums, set out general arrangements. Load considerations. Equipment, traffic, earthquake, hydrostatic, and erosion protection. Geotechnical considerations, subgrade, slope stability, strength and durability. Surface and subsurface drainage, material selection, and marine considerations. Utility services provision, corrosion protection, navigation aids, and protective works. Additional useful information: compliance checks. Verify conformance to codes, specifications, and regulatory requirements. Interdisciplinary coordination. Promote interdisciplinary coordination to ensure comprehensive design reviews. Standardization. Ensure standardization and compatibility with existing facilities for continuity. Testing and inspection. Address testing and inspection requirements to ensure design integrity. Documentation. Maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions to provide a clear audit trail. By following this structured guideline, the discipline design review process will ensure that all critical aspects of each design discipline are thoroughly considered and optimized for safety, efficiency, and compliance with project requirements. Design Review Guideline: Plant Operability and Maintainability. Scope: conduct a high-level review of the design, including the impact on performance, operation, and maintenance of the plant. Review timing: timing to be determined by the project engineering manager in consultation with lead discipline engineers or their designate. Methodology: review the facilities to ensure systems have been designed to satisfy performance, operation, and maintenance requirements. Intended outcomes: produce a review report listing and commenting on any inadequacies identified and recommending actions to ensure these are captured in the design. Recommended reference documents: basis of design, plant layout drawings, PNIDs, process calculations, equipment list, manning schedule, 3D model if available. Recommended team: facilitator, scribe, project engineering manager or designate, lead process engineer, project engineer, lead discipline engineers, customer representatives. System-specific prompts and scope: performance: ensure the design is fit for purpose and provides optimum performance. Compare the design to similar previous projects for benchmarking. Allow for future expansion within the design. Operation: assess manning requirements for normal and emergency operations. Review commissioning and operating procedures for various conditions. Ensure comprehensive training programs are in place. Maintenance: evaluate maintenance procedures and facilities to ensure ease of upkeep. Ensure availability of spare parts and maintenance manuals. Incorporate lifting equipment and access points for maintenance activities. Additional useful information: comparison with similar designs. Use lessons learned from previous projects to enhance the current design. Future-proofing: design with future expansions and upgrades in mind to avoid significant redesigns later. Operational efficiency: optimize the design for operational efficiency, considering factors such as energy consumption and ease of operation. Safety considerations: ensure that safety is a paramount consideration in the design, with clear procedures for emergency situations. Interdisciplinary coordination: facilitate coordination between different engineering disciplines to ensure comprehensive operability and maintainability considerations. Documentation: maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions, to provide a clear audit trail. By following this structured guideline, the plant operability and maintainability review process will ensure that all critical aspects of plant performance, operation, and maintenance are thoroughly considered and optimized for safety, efficiency, and compliance with project requirements. Design Review Guideline: Process Shutdown Philosophy. Scope: review the process shutdown philosophy diagrams to define the shutdown hierarchy levels for the facilities, ensuring all operating scenarios and interactions between existing and new facilities are considered. Review timing: timing to be determined by the project engineering manager in consultation with the lead process engineer and lead instrument controls engineer or their designate. Methodology: conduct a brainstorming review of the process shutdown philosophy diagrams using a top-down approach, starting with the highest shutdown level. Intended outcomes: agreement on the shutdown hierarchy levels for the facilities. Clearly define any hold areas and assign responsibility for clearing these holds during detailed engineering. Recommended reference documents: process shutdown philosophy diagrams, cause and effect charts. Recommended team: facilitator, scribe, lead process engineer, part-time, lead instrument control engineer, customer operations representatives. System-specific prompts and scope: shutdown hierarchy levels. Define and agree on the shutdown hierarchy levels for the facilities. Hold areas: identify any areas where decisions are pending, hold areas, and assign responsibility for resolving these issues. Operating scenarios: consider all different operating scenarios and interactions between existing and new facilities. Safety and risk: ensure that the shutdown philosophy addresses all safety and risk concerns, including emergency shutdowns and fail-safe conditions. Additional useful information: compliance checks. Verify that the shutdown philosophy complies with project scope, customer requirements, and relevant industry standards. Interdisciplinary coordination. Promote interdisciplinary coordination to ensure comprehensive review and understanding of the shutdown philosophy. Documentation. Maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions, to provide a clear audit trail. Training and procedures. Ensure that clear procedures and training are in place for all shutdown scenarios to ensure safe and effective operation. Emergency preparedness. Incorporate emergency shutdown procedures and ensure they are well understood by all relevant personnel. Regular updates. Update the shutdown philosophy regularly to reflect any changes in project scope, customer requirements, or industry standards. By following this structured guideline, the process shutdown philosophy review will ensure that all critical aspects of facility shutdowns are thoroughly considered and optimized for safety, efficiency, and compliance with project requirements. Design Review Guideline: Fire and Gas Detection. Scope: conduct a comprehensive review of the fire and gas F&G detection system design for gas, toxic, and fire detection, including manual alarm call MAC points. Review timing. Timing to be determined by the project engineering manager in consultation with lead discipline engineers or their designate. Methodology. Undertake a systematic multidiscipline review of key design documentation and features, including basis of design, safety design philosophy, fire zone layouts, F&G risk analysis cause and effect, charts, and F&G layouts. Intended outcomes. Issue a review report addressing the F&G detection system design features, including effectiveness, constructability, operability, non-compliance, corrective actions, and recommendations. Recommended reference documents: F&G cause and effect charts, F&G layouts, F&G risk analysis cause and effect RACE charts, fire zone drawings, facility layouts, safety design philosophy, area classification drawings, PNIDs, HVAC DNIDs, and process PFDs, BOD applicable sections, performance standards, other PNIDs drawings and data as required by the team, shutdown philosophy, shutdown diagrams, escape route layouts, area protection layouts, F&G detection design description, emergency system survivability analysis. Recommended team: facilitator, scribe, lead instrument engineer or delegate, lead safety and risk engineer or delegate, process engineer as required, customer operations and safety representative, safety case representative as required, customer instrument engineer. System-specific prompts and scope. Key features to consider: basis of design, BOD, and safety design philosophy. Ensure alignment with the project's foundational documents, statutory regulations, and design standards. Verify compliance with applicable laws and standards. Fire zone layouts and delineation. Ensure accurate and effective zoning for fire and gas detection. F&G race charts and hazards. Evaluate the accuracy and thoroughness of risk analysis and cause-effect relationships. Detector applications and alarm actions. Assess the suitability and placement of detectors, along with the corresponding alarm actions. Voting configuration and executive actions. Review the logic and implementation of voting systems and executive actions for detections. Failure of prescribed actions. Ensure contingency plans for failures in the detection system. Consistency across fire zones and packages. Verify uniformity in detection systems across different areas and packages. Accuracy of F&G layouts. Cross-check layout accuracy against physical models and drawings. Detector distribution and redundancy. Ensure adequate coverage and redundancy for critical areas. Access and site interference. Review detector accessibility and potential site interferences. Gas dispersion accumulation. Analyze potential gas dispersion and accumulation scenarios. Interaction, cross-voting. Evaluate the interaction between different detection systems. Spurious operation. Identify and mitigate risks of false alarms due to environmental factors. F&G equipment types. Review the selection process and suitability of F&G equipment. Maintenance, test, and reset requirements. Ensure provisions for maintenance, testing, and resetting of detectors. Compliance with F&G cause and effects charts. Verify adherence to the established cause and effect logic. Additional useful information. Effectiveness. Evaluate the hazard application and distribution of the F&G detection system. Constructability. Ensure the design integrity and site feasibility of the F&G system. Operability. Assess the accessibility, testing, maintenance, and reset features of the detection system. Non-compliance. Identify and document any deviations from the BOD and safety design philosophy. Corrective actions and recommendations. Provide actionable recommendations to address identified issues. Documentation. Maintain thorough documentation of all review activities, including meeting notes, action items, and resolutions, to provide a clear audit trail. By following this structured guideline, the fire and gas detection review process will ensure that all critical aspects of the detection system are thoroughly considered and optimized for safety, efficiency, and compliance with project requirements.